So the previous approach check every one of the big O n square subarrays. If we want to get a faster algorithm, we have to avoid checking every subarray. So can we do that? Now let's look at this example again. So here I have the elements in the array on the first row, the prefix sum in the second row. So let's look at the subarrays, because we know the subarray that have sum 6, we can find that from the prefix sum. So let's look at what they are reflected in the prefix sum. So we know the first subarray with sum 6 is 1, -1, 4, 2. And these subarrays sum up to 6, and that's because we have a 6 here and we have a 0 here. So 6 minus 0 is 6. So similarly, with this 4 and 2 sum up to 6, that's because of 6 minus 0 is 6. So the other subarray that sum up to 6, the other one is because ending here, there are two of them. One start from the beginning, one starting from here. And also there's one ending at the last position, which is 7. And that's because this 7 minus 1 is a 6. So the number of subarrays with sum 6 ending at each of the position, we have 2 here, and 1 here. And we have 2 here is because we have 1 6 here, and then we have 2 0 happen earlier. Similarly, because of the 2 0, there are 2 subarrays that sum up to 6 ending here. So the previous approach can be viewed as essentially for ending 6, it look at each of the previous element and see whether its a prefix sum is 0. Because if it's 0, then it contributes 1. But we don't have to look through all of them to look for 0. We can store the prefix sums using a histogram, and then we can directly look up, well, when we end here, how many zeros we happen before us. If there are more than one, so because there are 2, then that means there's a 2 subarray that sum out to 6. So when we are looking at this 4, we are looking for how many -2 happen before us, and there is none. So that's why there is 0 subarray ending here with subarray sum of 6. So by using histogram for subarray to store the prefix sums, we can reduce the complexity from n squared to n. Now let's look at the code using prefix histogram. So one potential problem is the sum may be negative value. So if we use an array to represent the histogram, then we have to sort of shift the index so that histogram 0 will represent will correspond with the maximum sum we are willing to tolerate. So here I set the maximum sum at 2 million. So then the array size will be 2 times that plus 1, because we are representing from negative max s to positive max s the histogram for each one of them. So we set this max s equals 1. This corresponds with 0. So because when we start at the beginning, we have a empty prefix. We have a single empty prefix sum that has value 0. So we set this histogram to be 1. Then we just loop through all the values in the array. Every time we compute the rounding sum, which is essentially the prefix sum, and then if we have this prefix sum to be this value, then what we are looking for is this value minus k to be that in the previous prefix sum. Because if we have some prefix as r sum minus k, then the subarray sum will be r sum minus k, which will be k. So we need to add the max s because we need to do this shifting to accommodate negative sums. So we add that, and then we update the histogram to reflect the fact that now we have we've seen one more prefix sum with the value R sum. So question is, does this code work? Should this code pass? So this code should not pass because this max s is not big enough. So because the array can contain up to 20,000 elements, each of them can be negative 1,000 to 1,000. So the range should be negative 2 times 10 to the 7 to positive 2 times 10 to the 7. So max s should be 2 times 10 to the 7 instead of 2 times 10 to the 6. So when I first tried this several months ago, using max s equals 10 to the 6 actually passes. So they didn't have test cases that are big enough, have big enough sum. But I just tried it today. Actually, now this one fails. So I will get index out of bound exception here. But if I set a larger max s to be 2 times 10 to the 7, it will be out of memory. So they cannot allocate an array of that big. So I think they added new test case to prevent this incorrect solution to pass. So here the problem is the total possible value of the prefix sum is too large to represent using an array. So what we should be doing is use a map, use a hash map. So then we only need to record the number of occurrences for the prefix sum that actually occur, which will be limited by the size of the array, which is 20,000. So here we use a hash map, which map a prefix sum to the number of times it occurs. So we use this hash map S is for that. So this is a code that try to do that. There are several bugs in this code. So I want you to look at this and then try to identify as many bugs as you can. Okay, so I assume that you've looked at the code and find maybe 1, maybe 2, maybe 3 bugs. So there are several of them. The first is we didn't have that initialization for the 0 prefix sum, so we need to add that. Before line 4, we need to have this s put 0, 1. And line 7 is also obviously wrong because we find this prefix sum. We shouldn't just say it occurred once. We really need to add 1 to the previous occurrence. So line 7 should be using the syntax starting with Java 8. You can use the merge. If you use the Java 7, then you need to sort of write your own routine to do that, or you need to write a few lines to achieve the same effect. Essentially checking if the sum does not exist, then you initialize it, you map it to 1. If it already exists, you add 1 to it. And line 6 is also wrong. In fact, it's wrong for 2 reasons. The first is you will get a null pointer exception when this get returns null. So you need to check if it's not null, then you add. Otherwise, you shouldn't add. And second, this k minus sum is wrong. It really should be sum minus k. So I guess depending on how you count, there is either 3 or 4 bugs in this code. And the complexity of this code is linear because there's only a single loop over all the elements, and inside the loop everything is a constant time. So the hash map operation is a constant time. So the lesson for this question is first, a subarray sum can be computed as different of 2 prefix sums. So this is from the previous topic. And also we can record the information of how many times the prefix sum has appeared using a histogram. So instead of storing the prefix sum in an array, we can maintain a histogram of it. Because what we want to do is look up from a sum value to how many times it occurs. And how to implement the histogram depends on the range of possible value. If the range of possible value is small, we can simply use an array. But if the range of possible value is large, we will need to use a map. So finally, thinking about counting how many solutions there exist ending at the index is actually fairly generic technique that we will encounter multiple times. Also, when we later we will when we encounter two-pointer in sliding window, it's easier to think about how many solutions there are ending at a particular index.